Once again, I want to pray to the demo gods because this is going to be a demo heavy session. I'm going to showcase how we can use Julia on Azure Cloud to build end-to-end data science solutions. Just want to know, like, how many of you know what Azure is? Is that a color, or is it a cloud, or is it? Okay, thank you. So Azure is Microsoft's cloud offering, and we're going to show how we can use Julia, and I'm going to demo a lot of services which can integrate well with Julia. And as we heard from a lot of speakers that the data is going to terabyte scale, and we don't know what it runs on my computer. I don't know about yours. So we are going to come to that and see how those issues can be solved if we switch to cloud and use this kind of work. So yeah, I'm going to basically talk about Azure. I'm going to talk about a data science virtual machine. It's a special machine. We'll go into it later on. And then I'll go and do demos how we can integrate Julia with SQL data warehouse, blob storage, a data lake, batch, Q&A, and then I'll conclude. And I know you guys must be finding these terms very, very obtuse. Believe me, all the Laplacian and Jacobians and all those were obtuse to me too. So it's a favor I'm returning back. But I'll try to explain them. All right. So when I look at the data science and intelligence, generally in a production environment, when we want to have a pipeline ready, we see this is my personal thought, this is how it is. So there is a range of event producers. It could be data coming from doctor's office. It could be social media. And then we basically ingest it. There's a system which takes care of all the data. It finds missing data. It marks records which are bad, etc. And then we transform it. And there are several services available. So the services names which you see here, like Event Hub, these are specific services which are available in Azure. If you go to Azure and search Event Hub, you will find something which is called Event Hub, and it can process and ingest a lot of data. So similarly, there are transform services available. For these services, you don't have to manage anything. You go, you create your account. You say, OK, I want to have an Event Hub, and there you go. You don't have to configure anything. You get everything managed by Microsoft. That's the benefit of the cloud. So going forward, you basically transform your data once you have it. And then you basically put it in long-term storage. The original data goes to long-term storage. Your intermediary results goes into long-term storage. And then there is a section of analytics, which takes that data, transformation, runs analytics on it. And this, although the flow is going from left to right, there are generally cycles. So from analytics, it will go to transform, it will go to storage, go back to analytics, and so on and so forth. And then eventually, the data is visualized or sent back to the devices which created it. For example, like in Meher's example, if a neonatal image is sent, the system can send back the results. Hey, this baby has this gestation period, maybe, whatever that was. So it can basically send back results of processing. So when I look at this and Julia, I feel like Julia fits into 3 layers, mainly, which is transform layer, where Julia code can be used to transform data, basically do TLC, ETL, not TLC. TLC is another internal library at Microsoft. I don't know why I mentioned that. There is an analytics role, which of course Julia plays, and there's also a visualization role. What I'm going to do is I'm going to talk about how Julia fits in transform, analytics, and how it can read data from storage. So I'm going to talk about SQL data warehouse. There's a petabyte scale data warehouse where you can store structured data, and you can query it through Julia. Then there is data lake. There's blob storage. Blob storage is very similar to S3. S3 blobs. Are you guys aware of Amazon's S3? Right, so it's very similar. It's an equivalent service. And then there's batch, which helps you run embarrassingly parallel workloads. And you can scale it up, down, as you feel like. And then the question is, where would Julia code run? And we propose that Julia code can run on this data science virtual machine. Has anybody used a data science virtual machine before in this room? Oh, thanks. I hope you don't work for Julia Computing. So data science virtual machine is a comprehensive cloud-based data science environment that empowers data scientists. What essentially does, it creates a developer data science desktop in the cloud. So as soon as you provision it, you get Julia installed in it. You get Juno Pro installed in it. You get Jupyter up and running with Julia kernel in it. So as soon as you get the machine, you can start coding and you can start doing your work without worrying about the configurations. It also comes with other tools, like it has R inbuilt, it has Python inbuilt, it has GPU drivers installed on it. So if you use a GPU VM, you can directly run GPU code on it. You don't have to worry about configuration, installation, and all that. There are other deep learning toolkits installed on it. For example, CNTK is there from Microsoft. There's TensorFlow. There's MXNext, SGB Boost. The whole thing is pre-installed on that machine. And there are several editors as well, like Visual Studio Code, Visual Studio. Git is installed. And this basically VM is available in 2 flavors, Linux and Windows. So if you're more familiar with Linux, go for it, or Windows, use that. And one of the interesting thing is that we want to give, as a team, we want to help people use this to operationalize their work. For example, you want, say, a REST API for the model that you have created. That's very easily possible with DSVM. We have several ways in which you can operationalize it, whether it's using Docker, whether it's using Spark, whether it's using Microsoft R services, Azure ML. I'm hoping we can also bring Julia Run to this set, so that you train your model, you get the data, and you operationalize. You get the data, you train your model, and you operationalize it all in one machine. Anyways, with that, I want to show you some examples because, of course, nobody believes in anybody's words, right? So we have to see something concretely. Okay, so what happened interestingly was that Berkeley was blocking all the Azure IP addresses. I think somebody was running a bot framework from Azure and pinging Berkeley, so they just blocked everything. So I could not connect to my remote VM. So what I'm doing is I connected to my work desktop, and from my work desktop, I'm connecting to Azure VM. Anyway, so there might be some issues while we do this. Okay. So just giving you an idea how it looks. Oh, there's nothing on the screen. Was it from the beginning or?
No, just as soon as you started clicking in, so we haven't missed anything.
Sorry, I was just.
I'm not good at wires.
Let's do it again. Okay, got it. Maybe I stepped on something. Okay. All right, so this is how like the data science virtual machine looks like. It's just a regular machine. It just has everything installed, pre-installed on it. So what I'm going to do is I'm going to go to this particular notebook. And in this notebook, we are going to connect to a SQL data warehouse, which is an Azure service. And this data warehouse allows you to store petabyte scale tables. And you don't have to do any management of the database per se. So no more need of a DBA or somebody to handle the database. So, and one thing I would like to emphasize on is like, there is no glue code written for it, and there is no more installation done on it except this notebook. So you can see how simple it is to use Azure services through Julia. So what I'm doing is very basic, setting up of server credentials. Now you know how to log into a SQL data warehouse. Okay, and then basically let me just go ahead and run this. Then I create a SQL connection string, which is a very standard process. And if you'll notice that this is using a particular driver. This driver is also pre-installed on the machine. So there's hardly any work to be done in terms of connectivity if you are a Julia user. So to do that, we just use the ODBC package, which is standard install in the Julia Pro. So again, no installation needed for anything. Now we'll go and run this. So what this this block of code is doing is it's creating a table. It's inserting a few dummy values, trying to retrieve those values, and then just drop the table. It's actually did finish. So again, this is Microsoft claims that this provides again a huge amount of data store, which might be useful. Any questions? I will make these examples available so that you don't have to Google. Okay. Is this still interesting? Just want to know. I have like few more demos. I can go to those. Okay. So another thing which I wanted to show is how we can connect to blob storage. Blob storage is a very generic object storage. You can drop any kind of file to it, and you can retrieve it later on. In this case, I'm using PyCall. PyCall, yeah, everybody's probably familiar with it. And I'm using an Azure SDK. This is an SDK, again, which is pre-installed on the machine. We just go ahead and access that. I'm setting up the credentials here for that blob storage. The blob storage name is DSVM Workshop. And then basically just go and list everything from it. So we have two objects on it. One is New York taxi data set, and there is another one which is volcano.1 as a JSON file. And then we can just easily retrieve the contents from that. So there you go. So again, this file could be as big as a 1 terabyte file. And this can store, yeah, there's no limit probably, upper limit of how much it can store on it. So with that out, let's see. Now another question like you might have is like, okay, you don't have data on those data stores. So how do you access that? Like say you have an on-prem data store, or you have your university database which has all this data. So how do you get it on DSVM, or how do you use this system? So there is another tool that we install on DSVM. It's called Apache Drill. Are you guys familiar with Apache Drill? Okay, fantastic. So I can talk about something new. So Apache Drill is a tool which allows you to connect to very different data sources. They claim that it can connect to almost anything. So with this pre-installed, all you have to do is configure. You have to figure out like what are the settings to connect to your data source, and you put that in Apache Drill config. I'll show it to you how to do that. So there's a drill console. So in this, we have currently enabled like 4 plugins: ADLS, which is Azure Data Lake. There's copy. There's distribute file system. There's DocDB. So I'll show you like how the connection string looks like. So this is how the connection string looks like for a data lake kind of store. And yeah, it's pretty standard. I mean, generally services, they publish their drill config file for you to use. So now what we're going to do is we're going to connect to this data lake. A data lake is a storage and compute facility which can store structured and unstructured data sets. This was internally developed for Bing, and once it was like really used by everybody in Microsoft, they thought, okay, we'll make it available for everyone. So, and it can scale storage and compute independent of each other. So you can have more compute on less storage, or you can have more storage, less compute, or you can have both huge. It can scale either ways. That's the benefit of this. So now we're going to connect to a drill, using drill. I'm connecting to a data lake store. One thing you would notice is that drill converts every data set into a SQL-like structured data set. So you can write SQL queries on any data source, which drill supports. So you would see I'm writing a SQL query on a CSV file. And that data set, yeah, it's still running. And there we go. So we did a group by on a CSV file which sits in a data lake store. And we could get all the data back, thankfully. Next, these days these document stores are very, very popular. I don't know if you've heard about Elasticsearch, MongoDB. So Microsoft has its own product called Cosmos DB. It's very similar. It actually uses MongoDB connections. And you can store graph data sets on it. You can store JSON documents on it, and you can store CSV files on it. So what I'm going to do is I'm going to query a JSON file. This is actually a JSON file called volcano. JSON, which we saw already in the blob store. I'm just going to query it as if it's a SQL file. So basically, Drill as a software allows us to convert a JSON file into a rectangular format. Of course, it's not possible for all the cases, but for some JSON files, you can do it. Sometimes there's nesting, and that becomes ugly. So yeah, we could retrieve data from a data lake, from a document store. Okay. Now I wanted to show you something which is outside of Jupyter, which is Azure Batch. So many times there's a need to run parallel processes. And sometimes the job is like massively parallelizable or embarrassingly parallel. In that scenarios, Azure Batch can be used. In Azure Batch, what you do is you basically say, okay, I want 100 virtual machines to be spin up. You can specify what kind of virtual machines you want. You can specify the image you want to run. In the image, I mean like Windows, Linux, or DSVM. The advantage of running DSVM is that if you run DSVM, you get all the installations that come with DSVM into that pool or the VM machines. Now, once you create this pool, you can submit tasks to it. You can say, hey, go do this parameter optimization on, say, random forest, and do this for 1,000 runs. So Batch would provide you a way to run all those tasks on that pool and give you error reports or status reports. And if a task fails, it can redo it. I was talking to somebody who was doing drug analysis. So they wanted to run drug analysis, doses analysis. So how much dose should be given to a patient? And that kind of usage is very, very massively parallel, because for each user, you run a different test. Those scenarios can run very well on Azure Batch. I'll quickly show you how this looks like on Azure portal. So this is the UI way of creating Azure resources. We can go and I've already created a batch account here. So just go and show you how it looks, just to give you an idea. One can create pools. I've already created a pool of 3 machines, and they are currently in a steady state, so I can use them right now. So what I'll go do is, I'll go and run this. So I'll run the code first because it takes a while, and then I'll explain to you what it's doing. So as an example, what I've done is I've taken the decision tree package, and I'm trying to do parameter selection for a random forest algorithm. So very, very dummy example. I say, okay, I want my number of features to be in the range of 1 to 4. I want the number of trees to be in this set. And then I want to run a simple task, it's actually named simple task, with these parameters in a batch scenario, which is like, I want to run it parallelly. So let's go and see what this simple program is. So this simple program is a Julia code, which is here. So very simple code. It basically takes that iris dataset which is available. It extracts the command line arguments, and it runs a cross validation on random forest with those features which were given as input parameter. Very, very simple example. So now that it's running, we can go and see what's going on. Okay. So now we can go to our jobs, because right now we just submitted a job to that pool. Pool was already created, we submitted a job. Now we can see that there are several tasks already active on that batch pool. We can go and check how this one looks like. You can go and see, show me the resource file. And there it is. It's a Julia code which is running on that pool. So, I mean, I showed a very simple example, but it's possible to have dependencies between the tasks. So you can build a DAG and then give it to the system. Okay. Any questions, concern at this point? Anything which I can clarify? Okay. Right. So let's go back. Okay. So this is the location where you can find all the demo code which I showed today. Oh, we already did all that. Showed drill, showed batch service. I made a UI just to, like an animation to show how it works. I don't know if I was able to explain it well or this looks better. But let's go. So that brings me to the end of my talk. And in the summary, we basically showed how Julia is well supported in Azure, and how we can connect to different data sources in Azure to take advantage of massively available computing and storage resources there. We showed, and I talked about data science virtual machine, which comes pre-packaged with most of the things. So yeah, feel free to use it. There's a way you can get started with it. I know there's a hackathon tomorrow, and if you guys want, you can use data science virtual machine for your hackathon. You can use the link at the bottom. It's for, it gives you 8 hours access to Linux DSVM. And the top link allows you to use any services in Azure as long as they are less than $200. It requires a credit card information, though. So, yeah. So, yeah, that's it. Thank you.